in one of our breaks, he'll raise his hand at that point and take you round. I'd also like now to introduce you to Chris, who'll be talking about our course and all the technical elements behind that. Thank you.
I can't see you. Ah, that's better. Hi, I'm Dr. Chris Nash. I'm the program leader and developer of the music production and software engineering degree that we run here at Point Blank. A very warm welcome to our Penn Street campus in London. So as Jess said, we're going to be doing a tour of the facilities, which is going to include the MuSE lab, which is a dedicated space for teaching audio programming. And my talk, I'm going to tell you a bit more about the course and some of the technologies that we use on the course designed to make designed to make audio programming a bit more accessible. So yeah. I'm going to be around throughout the night, so please do come up to me and ask me any questions about anything I talk about, but also anything about the MuSE degree or Point Blank. Yeah, I just wanted to also say it's great to be back working with the audio program again and to see Josh here in London again. So, I'm going to talk about, well, the degree a little bit, and then I'm going to focus on how we get people from no code to zero code within a year. And I'm going to focus on one module that we have, one of the three we have, which is basically how we introduce them to C++ by making them code 30 plugins. Some of this and some of the learning that C++ presents we tackle using a variety of different technologies. I'll be talking about those. I'll be talking about Klang. Raise your hands if you've heard of Klang with a K. Cool. And I'm going to be talking about Klang Studio, also known as RapIDE, which is basically a C++ IDE that runs inside a DAW plugin. And the whole idea is basically to make programming audio in C++ a little bit more live and a bit more expressive. I'm also going to talk about some of the innovative approaches we take to teaching audio programming here and how we use technologies to kind of tackle some of the problems that we have with kind of modern education and learning styles. I don't know if you know me, but I've worked in the industry as both a developer and a composer. And I've found a true passion for teaching and to kind of turning people to the dark side. And you can either choose that as audio programming or C++. But this gives me quite an interesting perspective, and so I'm out to tackle some of those problems. And the passion project at the moment is the music production and software engineering degree that we run here, or MuSE, as we call it. And the idea very much is that this is a professional degree. So this is all about getting people into the software development industry as audio programmers. So we're tackling the fact that people have lower digital literacy now. We're teaching them C++. And we're focusing on interacting with industry. So we've actually collaborated with industry to design this program, and we teach industry skills like agile programming and end-to-end development, which includes, believe it or not, testing as well. So there's the degree. I'm not going to go through everything, but broadly the plan is to go from zero code to ready for industry, and to actually address some of the problems because if you're in industry at the moment, you might kind of be slightly suspicious of graduates at the moment and whether they're ready for industry. I've heard some colorful metaphors used to describe them. So we spend the first year kind of trying to catch up, developing them as C++ programmers. And by the end of the second year, we want them to be at the kind of stage that you'd normally be at the end of a kind of music computing degree, so that the third year can focus purely on industry. And this first year is what I'm going to talk about today. I talked a little bit last time about computational thinking, where they learn to program through music and actually writing pieces of music using code. But this time I'm going to talk about the audio processing module. And it's their first introduction to C++. And as I say, we get them to write a rather large amount of plugins. In fact, every orange box there basically is a different plugin. So in 9 weeks, they write about 30 plugins, possibly a few more, and then have to design their own one. And they do it all in C++. So, easy. So how do I make it more accessible by what seemingly seems to be increasing the challenge? Because too much challenge for your ability and you get anxious, too little challenge and you get bored. And I think the risk here with C++ and audio programming is probably anxiety rather than boredom. So a lot of my research has been into how we support flow states with the design of software and music software specifically. And why do we want to do this? Well, because flow is associated with intrinsic motivation, which you can also just substitute for the word fun. And the evidence for this is if you're in flow, you get a distorted sense of time, i.e. time flies when you're having fun. But how do you actually create it? How do you support it in software? How do you make software or learning more likely to have the student in flow or the user in flow? Well, the key thing is fast feedback, basically, either as a teacher, but also in your programs. So a lot of my research has been on flow, but also how to improve the feedback cycles in different types of music software, including composition tools, but also now I've been looking at how we make the kind of feedback loop in programming a little bit faster. And the most important thing you can think about here is that it's multiple feedback loops. And because you've got the notation in the way, say the source code, or just the UI, you've got a feedback loop with that, but you've got to integrate it with the feedback loop with music or sound as well. Right, so very briefly, C++, like it or love it, it is the industry standard, and maybe for a while. So it has lots of positives, it has some negatives, and a lot of those negatives make it difficult to use to teach, basically. It's a very hard language to teach. It's general purpose, it's not designed for audio. It's very, very complex, I think we'd all agree, and it's getting more and more complex with every new language iteration. The tools we have for it are professional tools. They're free, so they're accessible economically, but they're not accessible to learners. But the good thing about C++ is that you can do a lot with it. It's very fast. You can use it in a lot of different places. But one of the big problems, you might have anticipated, is the feedback loop is pretty slow. So for a learner, you've got to write the code, compile the code, open your test platform, test the code, wait for it to crash, reflect, and some of those stages might even allow you an opportunity to go make a cup of tea. So it's not a fast feedback cycle. So it's a high ceiling, which is why we use it. And it's great creatively, and it's great for performance, but it's a high threshold, which makes it less than ideal for teaching and for learners and for getting started. So let's have a look at the teaching side. Well, because of the high threshold, and because at the same time we've got a reduced digital literacy at the moment because people are growing up with closed ecosystems and end-game usability, people are even less prepared now to learn C++. So the courses that did teach it at higher education increasingly aren't anymore, or they're simplifying it, or they're moving first-year content to second year, which is why graduates are not ready for industry, because they're not getting as far as they used to. Now, MuSE is obviously developed to tackle this problem and try and get people straight into industry. But I'm not the only one trying to solve this problem. Obviously, we think all the time about how do we make audio programming more accessible. A lot of degrees will teach Max or pure data or visual programming language. But even with Rainbow, we kind of get trapped in the box. So a lot of other projects have been started to try and make audio processing, even in professional practice, a bit more accessible or just a bit more audio. But one thing I noticed was there's another aspect of C++ we haven't thought about, which is it's very, very adaptable. It's a bit like the English language. If another language has a good idea, we just steal it. So what we can actually do is we can write a programming language inside C++ without leaving C++. We call those embedded domain-specific languages. So something that looks like a specialist audio programming language, but isn't. So what if C++ had built-in audio semantics? So this is what Klang is, and the Klang is one of the tools we use on this module, basically to try and make C++ more accessible. But if they learn Klang, they kind of are secretly learning C++ as well, because it is C++. So effectively, it's a very, very thin layer that goes on top of C++. You include it in the C++ project using a single header, and then it opens up different semantics that you can use for audio. And so the idea is to lower the threshold for beginners, but to keep that C++ ceiling for creativity and performance, and to use it in every place that you use C++ at the moment. So some code there on the right, that is the code for a complete subtractive synthesizer. Not the most complicated one, but it's fully contained and will run, and you can almost read it like pseudocode, and that's one of the design goals of Klang, is that it should be readable by someone in audio, and you can pick up the C++ if you want to use it in a project in production. So for example, the block diagram on the left becomes the code on the right. And it's basically just taking advantage of modern C++ tools, operator overloading and things like that, to make it to add syntactic sugar, to make it read better, to make it more like audio. There's no building graphs, there's nothing in the background that's happening without you knowing about it. It is just C++. It performs like C++, and actually when you compile it, all of this layers, this syntactic sugar, basically compiles away, and you end up with the code that you would have written, albeit with 20 lines of C++. So there's if you want to investigate the project or use it, it's open source. So if you want to download the language, it can be used in any C++ project. So with a C++ 17 compiler on any platform. There's juice templates. I'm working on console and Raspberry Pi support at the moment. But I'm really keen for people to get involved, to stress test it. And yeah, I've been developing lots of examples. So there's about 40 plugins that are up there that you can see. But I'm going to, basically just make them all open source and release them. But if other people want to kind of contribute, we could have this kind of repository of DSP in C++ that people could use in their own projects and share. So I fixed it, right? Except, of course, that C++ is only one of the problems. And actually, if I was to be honest about what's the biggest blocker for learners, it's the fact that they can never get Visual Studio or Xcode installed in the first place. And if you lose them to that on the first week, you've lost them entirely, okay? If they'll disengage from the teaching. So actually, we need something that is more streamlined, focused on audio compared to Visual Studio. And they're amazing tools, but who in the room actually knows all the topic? I actually have a colleague in the Visual Studio development team, and he doesn't know what all the features do. So what I've done is developed an IDE that runs inside a DAW plugin. Okay, so you can load the synthesizer, you can load the effect, and then you can just click Edit C++. So there you go. There's a plugin that you could load as an audio unit or as a visual VST. You make it a bit bigger. You see there's a bit more to this plugin, some analysis tools. Okay, and then there's a button that says Edit C++. You click that, and you've got a complete IDE which has a full LLVM Klang with a C, a tool chain built into it. And on the Windows version, you've even got things like interactive debugging, so you can stop the plugin inside the middle of the DAW as it's playing, have a look around, poke it a bit, and then start, continue it. And it's got hot rebuilding and things like that. So the whole idea is to make it live and instant. You can play with different ideas. So great for learners to understand things, but also great for prototyping. And so when I'm coding with this and come up with examples, it's more of a process of sound design. I'm actually thinking in terms of sound rather than code. So it's actually quite a different experience. Again, that's free as well. But I'm going to give you a very quick demo of it. So here it is running. This is running in just the Juice demo plugin host, but it'll run in any compatible audio unit or VST host. And so there we go. This is a plugin. It's not necessarily the most exciting plugin in the world, but we're running inside the plugin. Everything is contained inside the plugin, and you can see I've just built it, and it's updated the plugin, and I can live build it, and I can go flibble. and rebuild it. And the plugin changes. I don't have to restart the host. I don't have to restart the ID or anything. So to show you some of the things, so the whole effect plugin is here. I'm going to do, I think, probably just a simple distortion plugin. We've got, well, first of all, we need to make it go up to 11. And then, so now we're potentially overdriving it. We obviously so this on the course, this is how we teach if statements. Okay, so we do a hard clipping plugin by just going if, so let's do in. So you see sometimes I can just use C++, other times there's a little bit of syntactic sugar to help me. Probably going to make a mistake. Right. Yep, there you go. Told you I was going to make a mistake. It's a classic mistake too. Right, so hopefully now we should have no distortion. Okay, so a very, very simple hard clipping function. But the students now learn if statements. Okay, and now we'll teach them functions. So I'll take them out here and I'll go, right, let's have a simple C function called clip, which takes an input of in, must make it neat. Okay. Okay, so great. So now I can go like this. They're still very C style, but you know, slightly cleaner process function down there. Does it still work? Good. Yes. But what Klang provides is kind of like special tools, and the studio as well, special tools to help you develop. So we can use the function object, and we can turn this little C function into a Klang function, and so now I can literally do the overdrive and stick it through the function as part of the signal process. Again, this should sound exactly the same. But the whole idea is to make that process function look more like a block diagram. So some of the other tools that we can do and use, which are useful, is, oh, it's a function now. Shall we have a look at what it looks like? Okay, I need to extend the axes a little bit so that we can see that classic shape. There you go. Ooh, and I have identified an error. There we go. That's better. And this allows me to work with arbitrarily complex functions and things like that. And so the environment also has the ability to plot impulse responses, and you've got all the analysis tools that you wouldn't have in an IDE and things like that. And you've got this kind of tools to help debug audio, which can be very, very difficult. So for example, if I want to look at actually what's being affected, I could just send the input signal to the debug output, which is a dedicated debug output that we may know from things, visual programming languages. It's lovely to just be able to see what the signal looks like at different stages. So if I can see them both at the same time now. So the yellow line is the debug signal and just the input, i.e. the dry, and the white line is the wet. So this is a tool that we use. And this is how we're able to get through 30 plugins in 9 weeks. But it also means that it's just so much faster to start, it's so much easier, there's fewer pitfalls, it's so much more embedded in audio, and you can teach C++ with meaningful interactions with audio, and making synthesizers and effects and things. Another aspect to it, which I actually will encourage you to try, is we've developed a custom virtual learning environment, which is basically just different interactive online learning. So you've got an online C++ compiler, exercises, and we're teaching a very visual style. So again, so you see the one down here, you can actually code inside the browser, click compile, and that's your first way, steps in learning audio. We don't hear the audio, you're not connected to audio at that stage, but we do see it, and therefore we can understand things like gain and distortion. And you can plot graphs, and it's very integrated with Klang. So you come to an exercise like this one on the left here, you click on it, and it kind of loads in Klang with the starting point and then walks you through the different steps. And so this is how we teach the audio processing module. And so I don't know how much time I have, so I'm going to actually just leave it to you to try. Because basically, it is now available through the audio programmer, with kind of a taster of it, so a kind of 4 modules to give it a go. And the first module is actually free. So if you want to see the kind of technologies at play and kind of see how we're teaching students, you can have a go. And then, if you want to drop, the other 3 modules are good fun as well. So there's distortion, subtractive synthesizer, and supersaw. Give it a go. Any questions, come and or just drop me an email, basically. Thank you very much. So yeah, we've got some of the students who are currently doing the audio processing module in the room at the moment. We've got the lecturer who's in the room, Davida. Yeah, there he is. And you've got me. So if you have any questions about this, all the tools, basically Klang and Klang Studio, are completely free. So if you want to give them a go, yeah, just download them. Just go to nash.audio. And yeah, if you can't find them, C++ is probably too much of a stretch for you. But okay, any questions? I can't see anyone. I can see some tumbleweed. Right, how are we doing for time? Ahead of schedule, right, in that case. Let's go back in here, and I will show you a bit more of Klang. If I switch over to the synthesizer mode, I want to demonstrate some of the kind of other end. So I talked about how we lowered the threshold, but maybe I've accidentally lowered the ceiling as well. And so one of the things I'm trying to do is kind of stress test it as much as possible by just implementing as much as I can. So there's lots of course materials here, some quintessential stuff, and so I thought, why don't we give a DX7 a go? So yeah, it's obviously longer than the example I showed you earlier, but there's about 95% of the DX7 functionality in this single file. And so let's build it and see what it sounds like. This is basically 4 presets. So that's the quintessential tubular bells, I think somewhere down here. Yeah, you just put some reverb on that, and that's the start of Top Gun. But yeah, what I'm trying to do is find out where the language is expressive, concise, and then, when it's not, fix it. But to be able to do a kind of a DX7 emulator in what is 350 lines of code, I can count as a win. So I'm going to switch over now and just show you, because it's C++, so it works everywhere that C++ works. This is the VLE, by the way, so you can see the interaction here. So this would be their first introduction to code. So if I just times in by out and click compile, the white line is the input, the orange line is the output, and we can see it's been halved in amplitude. Or we can link it to a slider, just to kind of demonstrate that this is live running code. And the student can instantly see the effect that just that one line of code is happening on the audio. Okay, and then if I go over to here, as I said, it's just C++. So anywhere you can use C++, you can compile Klang stuff too. So these are all WebAssembly, basically. And this is my personal favorite. You need to turn this one on first. And obviously, it's a very recognizable and entirely not copyrighted sound. But actually, it turns out to be a really nice synthesizer inside, because actually, if you just leave it statically on one of those settings, you get this kind of like, well, a sound that really needs an almond break. But yeah, other examples there as well. So some physical modeling. You know how the rest goes. Or we can have some fun with that. And the whole idea is basically just to make audio programming a bit more fun. Right. But, thank you very much. Yeah, please join me. I think so.
Hello. All right. Yeah, thank you. Thank you so much for coming. Everybody give it up for Chris Nash. Woo! All right. We're going to have a little 5-minute break, and then we will welcome our next talker. And go ahead and grab a drink, and we'll see you in 5 minutes.
So one thing I forgot to say, the next project in the Klang roadmap is procedural audio. So I'm integrating it with the Unreal Engine. And so I'm recreating the whole of Britain. And I think Britain has a few sounds. So yeah, the idea is I'm going to procedurally generate the entire soundtrack with Klang and Manhattan.
Fantastic.
So any questions about that? Or if you'd like to see it, let me know.
All right. See you in 5. please. And please feel free to come up towards the front as well. We want to see your beautiful faces. Don't be shy. I feel like I'm doing stand-up comedy up here. Yeah, come on back to your seats. Come join us. While you're getting seated, I just wanted to take a moment to give a thanks to our sponsors, Focusrite, Point Blank, Moonbase, and Audio Tool. And a big thanks especially to Point Blank for allowing us to use this amazing space. Please give it up for Point Blank for allowing us to have this space. Woo! All right, just wanted to do an introduction for our next speaker, who is Silas Geiger. He's came all the way from Germany to come speak with us today, and he's from a company called Audio Tool. So I met Andreas and Myrta from Audio Tool, who are two of the founders. They have a web DAW by the same name, and they're working on some really interesting stuff that I think could really make a difference, and they have some very innovative perspectives on what's next for audio software development, and also for how we're going to create in the future. One of those is what's called Nexus apps, which is what Silas is going to speak about today. And this is the idea of being able to take parts of their DAW, Audio Tool, and being able to manipulate those and create new applications with those. So I think something a little bit like Traction Engine, but also with its own little spin on it as well. And without further delay, I'll go ahead and pass it on to Silas. Take it away.
Thank you. Welcome, everyone. Today I have the pleasure to show to you all what we are building at Audio Tool, which is a DAW, but also a platform. We call it the Nexus platform. Audio Tool, some of you might know it. It has existed for over 16 years. But 3 years ago, we started to rebuild it from scratch in a small team of about 80 people at Audio Tool. So, yeah. I'm just going to start right off with a live demo of the whole thing to give you an idea of what I'm going to be talking about. So Audio Tool is a DAW, but it runs in the browser. And you can just go right now to beta.audiotool.com, sign up and start working with it. It's completely free. I opened beta here, and I'm just going to use a template project here at the bottom to give you something to listen to. I'm just going to start playing. And I just want to real quick give you an overview of the features of the DAW. I'm sure most of you are very familiar with what you're seeing here. So we have a timeline here with notes and with automation tracks. We have a mixer to the left, like most DAWs have, with EQs and compressors. We have timeline tracks, as you can see here, with solo and mute. And down here we have like the sound bar, which shows you Ableton style, the way the signal flows from left to right. You can rearrange devices here. What's a little bit different about Audio Tool compared to other DAWs is the way that the devices are configured. So if I click on a device, I can configure it, and what that does is it opens the studio view at the bottom, which is like basically a large desktop where all the devices in the project are laid out and they're patched together using cables. So you can actually see the signal, the way the signal flows through the cables, through the devices, through the effects, into the stage box. I'll just loop something here so we can hear something. And yeah. Now, on the left here, we have a library with many devices that we can add. So we have all these effects, this synthesizer, these drum machines. I'm just gonna apply some things here to show you something. So here, let's solo this percussion track right here. And then we can maybe drag a delay onto it. And as you can see, the delay is inserted down here. Signal flows through the delay. You can adjust it, maybe add a flanger or something also in here. It's inserted as well. Then we can automate parameters. So this enables or disables the flanger. Just going to automate that here. Focus on the timeline on the part that we're supposed to be looping. Let's just go here. insert automation region, and yeah, so you can work like you're probably used to in most DAWs, automate parameters and so on and so forth. So let's do this. Something like this, yeah. So this is basically a real DAW in the browser. You don't have to install anything, you can just open the website and start working. What makes AudioTool a bit different from other DAWs is that it's collaborative. So what I'm going to do now is I'm just going to open a new window, enter the same URL again, which will make my browser connect to the same project. And now you can see here, yeah, it could crash here, still in beta phase. So let's go jump back in here. So the left tab right now is producing the audio, but the right tab has the project open as well. I can just show you real quick how the collaborative work looks like. So let's maybe focus on the studio here and here as well. And right now I'm thinking maybe I'll add a synthesizer or a Heisenberg that we have here. Then go back to the timeline perhaps, insert a node region. Scroll down here, so you can see on the left side, as I'm working on the right-hand side, the left side will update as well as at the same time as the left side. So let's just add some melody here, like this. Then perhaps we apply a preset. This will open the preset library. This is the preset library where a collaborative online DAW has existed for a long time. So we have a massive library of presets, like tens of thousands of presets, as well as samples that we can use when working on AudioTool. And then maybe we'll add a pulsar delay and a quasar reverb, which are like advanced delays and reverb effects, basically. And yeah, so this is right now, I'm working on my computer. I have two tabs connected to the same project, but this right-hand tab could be anywhere in the world, could be in LA, could be in Sydney, doesn't matter. We're in the same session, we're working together. So this is our DAW. Yeah, let's close these tabs real quick. But what I'm going to talk about today mostly is Nexus apps. Nexus apps are apps that connect to a project alongside the DAW. And if you go to the beta launch page down here, you have a few curated apps already. I'm going to start with this app called TechnoRact. As you can see here, this is a separate new website hosted on some other domain than AudioTool. It's made by my coworker Krillo. And I can just press here, new project. This will open the DAW tab again. I'm going to move it to the right here. So now on the left-hand side, we have this foreign page, different domain, different author from AudioTool. And on the right-hand side, we have a connected project that's currently completely empty. And what we now can do here, the app that was developed here is a techno generator, which generates random techno tracks. And if I press on random up here, randomize, it will fill up this project with different regions, different nodes, different devices on the desktop. It will configure the mixer here on the left. And we can now start listening to techno that's randomly generated here. And the app is actually connected in real time to the project data structure. So you can see here, this app was designed so that the kick, if I click this button, it will regenerate a new kick pattern. So if I click this button here, it will generate randomly new kick pattern. And on the right side, you can see the region will update immediately with the new pattern that the app generated. So I can generate all of these things, and the app can do basically anything in the project data structure whatsoever. And so right now we created a new project for the Techno app, but I can also choose to say, okay, I'm going to close it. Let me just look at the key that the Techno app provided here, close it, maybe open a different app. Sorry, what was the key? I forgot. Let's connect real quick again. G# minor. So here I open a different app, and this time I'm not going to create a new project. It's just going to press connect and enter the project URL and press go, and then this app will connect to the same project at the same time. Now this app is actually completely vibe coded by someone who claims they don't write a single line of JavaScript code. They just use cursor to write everything that you see on the left-hand side. So in this case, it's a arrangement editor. So here we have G# minor. We can go in here and say, okay, G# minor, and then select some melody in here. And now if we scroll down here, we can see that this app also wrote to the same project some new regions at the start. So let's listen to them. And they should be in the same key as the other app because we just selected the same key. And this app has chosen to allow to add like different bass tracks, guitar, maybe even drums, and it's all in the same key. So we have two apps written by completely different people, hosted on entirely different domains that are working on the same project at the same time. Yeah. So now, So let me talk real quick about the backend infrastructure. Just pause this for this. So something you might notice if I press mute here, it's pretty fast, the mute button. When I press it here, it appears here on the right, but it's not quite instant yet. And the reason for that is actually because the messages that are sent that say, tell to the project, please mute this channel, are currently going to the United States and then back to my computer. And with Lightspeed, there is just so much you can do. But actually, last week, we just deployed a new backend that allows us to host these servers that are hosting these collab sessions anywhere in the world. So the general multiplayer infrastructure architecture is such that different clients connect to a central server, that is the multiplayer server that brokers messages. And these servers will be able to be hosted anywhere in the world, be it in the US, in Europe, in Australia, and China, wherever. And they're actually extremely lightweight. We will be able to push them even down to the edge. So meaning if you join a collab session from London, you will get a server that's around the corner, basically in London. Or even, and our backend developer has already tried this, you can even host them on a Raspberry Pi. They're extremely lean. They use a few hundred megabytes of RAM and have a CPU, basically. And so these collab servers, they can be hosted anywhere, and you can run any audio tool project on them. So far to the demo. Now I want to talk a bit more about the architecture of this multiplayer platform, what makes it run. So first, when we implemented this, we had to think about how do we store and save and load audio tool project files. And the way we do this is using protocol buffers. If you don't know protocol buffers, they're a schema language created by Google that basically allow you to create a schema of a data structure. They use the term message, saying message notice, position ticks, pitch, whatever, anything you want to include in them. And based on the schema language, you can then generate language bindings for any language you choose, TypeScript, Rust, Go, whatever, and read and write these messages in a type-safe way and serialize them to binary in a very efficient way. So this is how we, and then the audio tool project is structured in what we call entities. So these are these message blobs. We have a message blob for a node cable, node region, Heisenberg, synthesizer, node track, mixer channel, automation event. Everything you see in the DAW is basically an entity, which is a small message blob. And the audio tool project is simply a set of these entities. Entities can have pointers between them to create semantic relationship, like a node belongs to this track. But overall, it's just an unordered set of entities. So this is how we store and load the project structure. But we're in a collaborative DAW, and if a user makes a change, we have to somehow efficiently communicate that change. So we have 3 messages that allow us to communicate changes to this project structure. It's just create an entity from scratch, so insert an entity message into the set, update a field of an entity, so a single value, and remove an entity. So this is the entire change protocol, create, update, remove. And every time a user does something in the DAW, move a parameter, move a node, this is always converted in one of these 3 messages or multiple of these 3 messages. Then the way it works is, so we have the central server that brokers these messages. Every DAW that's connected to it checks what is the user currently doing and converts these actions into these modification messages and sends them to the server. So, and then the server will receive all these messages and actually put them in a definitive order, so like a committed history order, we call it, where the server says, okay, first this message and this message and this message, and then due to the multiplayer nature, it might happen that some messages become invalid, then we'll reject these messages. And then the server sends back this modification history back to the clients, where we do what we call consolidation. So the consolidation algorithm has a list of local modification that the user has already done. It's already applied to the document, to the set, and then it receives the committed modification history from the server that we can see here. So here the server has confirmed P1, but then it inserted a foreign modification history, and then P2, and it rejected P3, for example. And the consolidator will then try to reorder and cleverly generate a modification history it can apply on top of the local history to bring the two states back in sync. And this consolidation algorithm basically runs 60 times a second. There's a stream of outgoing messages, a stream of incoming messages, and every time it runs, it just checks what are the last few messages I received or sent, and I consolidate them and apply them to the local document state. So, okay, we just heard how to load and save and load projects. We heard how to communicate changes. We heard how to consolidate modification histories so we can actually sync with the backend state. But now, like, what do we do with this? So what we built at AudioTool is a JavaScript package, which we call the Nexus SDK. You can install it like this, npm install AudioTool Nexus, and this package allows you to read and write AudioTool projects in their entirety in very simple steps. I'd like to show you a few pieces of code that show every single Nexus app, how to set up a Nexus app, basically. So if you install the package, first you want to authorize your user, so you can make changes on the user's behalf. And I already had logged into, for example, Technoract here. I can press logout here. So what you do first is you call get login status, which will check local storage if there are authentication tokens already there. And then if you're not logged in, you call status.login, which opens a new page, AudioTool authorization page, where the user can press allow, gets back to your page, and then immediately you're logged in and you can continue working. So these 3 lines already will allow your app to be authorized to make actions on the user's behalf. Then what you want to do is first create an AudioTool client, which is authorized with the status. So now the client can be used to make API calls. And from the client, you can create a Nexus document, so a synchronized AudioTool document. And what you can pass in here is simply a URL from the DAW, and it will already connect to that document. You can, of course, also make API calls like create a new project or list me the user's project so they can select something. But this line here will create this Nexus document, this Nexus object, and after calling nexus.start, the Nexus object is now this AudioTool document that is synced in real time. So when you call start, a sync loop will start in the background, and it will continuously sync up with the server. So in your app, you now have the full project state of an AudioTool document in your app. Then what do you want to do with Nexus object? First, you want to maybe modify the project. So what you have to do there is call create transaction. This will first lock the document, so freeze it in place. So you have some time to breathe, basically, and work on a project state that doesn't continuously change as you're working on it. And then you can do one of the 3 modifications I mentioned before. So you could, for example, say, I want to create a TinyGain entity. TinyGain is this device on the desktop. So if you call this method in your app, immediately on the DAW, you will see this TinyGain appearing on the desktop. Then you can create an update modification. Say, okay, I want to update the gain field. This will cause the TinyGain's parameter, as you can see here to the right, to move. And then you can, of course, also say remove. Finally, call t.send, which unlocks the document and sends the transaction to the backend and syncs back up your local state. So these are the 3 modifications I mentioned before, but there are, of course, more methods that make it more comfortable to use the SDK. And something to mention here, the SDK is actually extracted from our DAW code base. So we started out just writing this package, not really a package, just like a framework in our DAW code base to keep the DAW synced with the backend state. And at some point we noticed actually we can just like extract that to a package and let everybody do that same thing. So the code you see here is actually used in the DAW. So if you move a parameter in the DAW, there's somewhere in the code t.update being called. So the DAW is really like a benchmark of what you can do with the SDK. Yeah, what else might you want to do with the SDK? You might want to react to changes that someone else does. So for example, we're going to say, I want to log to the console when someone creates a TinyGain on the project. Then you call nexus.events.onCreate. This will cause this line to be executed whenever some user connected to the project inserts a TinyGain into their project. And there are other methods like onUpdate and some other useful methods. So here we get a message when someone turns the tiny gain knob, for example. The JavaScript package itself is made to run on most JavaScript runtimes. So for one in the browser, the two apps we saw before are purely client-side. They're deployed on GitHub Pages. They don't need a server-side at all, but you can also run it in Node. No, excuse me. In Node, Bun, and Dino. And yeah, so this is for JavaScript package. The raw entity definitions and the sync protocol is, as I mentioned, expressed in protobuf, so you can also use Python, Rust, or Go, or any language you really know. There is protobuf compilers for every language you know. For these, of course, the consolidation algorithm might be a bit complicated to implement, but you can always just read projects, make statistics, or visualizations, or whatever you want. So yeah, so with the Nexus package, we have a new kind of plugin, I guess, to a DAW, where people can build apps that can read and write entire projects from scratch. But we still don't have audio processors. So for audio processors at AudioTool, we're currently working, or we have integrated VSTs. Now you might know VSTs are built mostly to run natively on the computer, and the browser is not capable of running VSTs out of the box. So the way we do this, our audio engine is entirely implemented in Rust and runs as WebAssembly in the browser, but which gives us some performance benefits. But it also allows us to run the audio engine locally. And this is what we also do. We provide a booster application that you can start alongside the DAW. And then when you open the DAW in the browser will connect to the booster application, and you will hear audio out of the booster running natively rather than in the DAW, which gives some performance benefits perhaps, but most importantly, it gives you the ability to actually run VST plugins as part of an AudioTool project. And in the current version, we have the Spitfire Labs plugin already implemented, so you can drag a Labs plugin onto the desktop and hear Labs as part of your AudioTool project running it. Now, yeah, so this is our current state at AudioTool, and I want to talk real quick about the future. So we have two parts. So first is, I talked before, we have Spitfire Labs plugin support, which is a really cool plugin, but of course we want to have general plugins. So we have actually general support for VST plugins already implemented. We just have to finish up and integrate it properly. And I have two videos here of what's coming next to AudioTool. So the first thing is general VST support. I'm just going to play this video real quick. It shows Serum being used in AudioTool. So here we can see this is just a mock plugin created by our audio engine developer that allows him to load arbitrary VSTs on his computer. He enters the file path of the Serum, and presses open, and then Serum will open for him in the project, and then he can actually use AudioTool to. Can you hear that? Can you hear that? No. Yeah. So that's so this was Serum playing the notes that he just entered in his MIDI editor. So yeah, that's the first thing. The second thing we also want to support is have Nexus app not just talk through our backend server with our DAW, because even if the Collab server runs in your studio locally, it's a bit clunky, and there will never be zero latency overall. So what we also want to enable is have cross-tab communication between foreignly hosted Nexus apps and our DAW. And here I have a quick showcase of that in action. This will come soon as well. This will allow you to actually write, for example, dispatch notes, dispatch parameter updates, play, pause, record the DAW programmatically as well. Notes on this Heisenberg right here. I can go in here, say low preset, and for example, use any preset. And this tab is the one that's scheduling notes, so they're not actually written in Nexus in here. They're just dispatched across tabs we were missing so far. And what I can also do is in the end press record here. and this will record the MIDI notes that my apps just dispatched. So I can even record a session that was played live on the left side. Notes on this. So yeah, so this is the third piece. So we have, to summarize real quick, so we have this app platform where we can read and write projects in a collaborative session that potentially is joined by multiple people and multiple apps at the same time. Then we have VST support, which of course we also want to have in the browser as well. I think we're going to hear a talk later about that as well, how to run engine plugins in the browser, clap, I think. And so we have audio processors, and finally we have node generators as plugins. All of these things combined three things combined will allow you to programmatically control basically every aspect of your DAW. And we think in the age of agents, where the entry point for programming something for people who want to just make art is going to be much, much lower. This is going to expand the possibility of what can creatively be done by a lot of people very easily. So yes, thank you a lot for your talk, for listening to me. This is the website, the developer.audiotool.com. You can go there, you can download the JavaScript package. We also have a new Discord server where we're trying to build a community for developers that build on Audio Tool. If you're interested, you can scan this QR code, but you can also just go to the developer platform itself, and there's going to be a Discord link up here sometimes behind this thing. Yeah, there we go. Yeah, thanks a lot for listening.
Thank you so much, Silas. This fantastic talk, and it's really exciting, the potential for where audio applications are going and they seem to naturally, organically be going towards the things that I think a lot of people in this room want, which are things like collaboration, being able to take apps that are not plugins, being able to pipe them into your DAW, things like running your plugins on the web. So all of this feels like a very exciting space right now. So yes, one more time for Silas, please. All right, we're going to take another 5-minute break, and then we will be back for the next talk. So see you in 5 minutes.
You can sit closer. I've had a shower today and everything.
Yeah, come on up. By the way, my wife let me know that I didn't introduce myself, so my name is Josh, for anybody that doesn't know me. I'm the founder of the Audio Programmer. Welcome, thank you for coming. Yeah, and with that, this is a longtime friend of mine. He's been one of the most active members on our Discord community that I know, and he is one of the best DSP engineers I also know. So if you need some DSP, this is the person to talk to. But ironically, he's not talking about DSP today.
Yeah, I'll cover that at the end. Yeah.
He's come down from Cambridge today, a good friend, and thank you for coming down. His name is Geraint Luff, and he's going to be talking about clap plugins and running plugins anywhere. So our last talk was about collaboration, one thing that many people want to happen. And another thing that people always say, hey, I would really love it if there was a way to get plugins and be able to run them in the web. And Geraint is going to tell you how to do that. So with no further delay, take it away, Geraint.
Hi. I'm really used to standing up for these presentations so I can walk around. So I might have a lot of pent-up energy. Let's see. Hi, I'm Geraint. I'm Signalsmith. I'm one half of Signalsmith Audio, the other being my partner who handles the business, everything, and somehow makes the company profitable. Yep, as Josh said, I mostly do DSP and a lot of talks. I'm here not talking about DSP, but about something else, because I have in my time written a few plugins for a few different APIs, different SDKs. And I've also written a few effect graph schedulers and that kind of thing. So I care a little bit about how audio plugins work, and how they're designed, and the sort of infrastructure and the technology behind the actual sound, and making it nice. Because I also really hate build tools. Just personally, I don't get on with them. So I'm on a mission for simplicity and reliability here. Clap stands for the Clever Audio Plugin. If you, it's Clap. It's a plain C API. For those who don't know, you just deal with sort of pointers to structs in memory and function pointers for things you need to do. I really like it. I think it's the nicest API I've personally ever used, and it has a really nice extension system and a single entry point, and it's got good documentation and good tools around it. There's native DAW support that's growing, but also the official build tools, so you can write a clap and then kind of package that into a VST or other formats, is good. And that also applies to languages that aren't C or C++. So if you write your clap plugin in Rust, then you can use this same wrapper to wrap that into a VST3 that you've essentially written in Rust. And I think it's a really good way to work. And it has some, I'm not going to tell you all the reasons why I think it's an improvement, but I really like it is. And it's a real format. It's pretty new to the space compared to some of the more established ones, but it has been battle tested. Now, WebClap, or WClap, which you can say like a sort of Superman sound effect in a comic book. This is, you just take a clap and you compile it to a WebAssembly module. That's it, thank you very much. I've been Signalsmith. No, so why would you want to do this? And firstly, I need to give an overview of what WebAssembly is for people who aren't familiar with it, if you're not a web person. Despite web in the name, it's not actually exclusively a web technology. It is a kind of a virtual CPU architecture. So you might think, oh, I'm compiling for ARM, I'm compiling for x86. I'm now compiling for WebAssembly. It's a target, and an increasing number of compilers and languages can output this architecture. And then to run it, it translates quite nicely to the CPU native ones. It can be either 32 or 64-bit. You don't really have to choose. There's just different instructions in the same set, so it's not really very opinionated. The modules are self-contained, so you download something and it has everything it needs inside it. You can import or export like the raw memory, functions, and numbers, which you can use as pointers. And you might have noticed that those are all the things that Clap uses. So the thing is that a WebAssembly module is just computation. It doesn't have access to the system, doesn't have access to anything outside of itself and anything that you pass in when you're constructing the module. As an example, if the WebAssembly is the CPU architecture, WASI is WebAssembly System Interface. It's sort of the OS, I guess you could call it, but you target WebAssembly WASI if you want things like file system access, but it's still sandboxed. So when you run one of these modules, you only get access to the bits of the system or the capabilities that you, when you're running it, decide are safe. It's still under development. They're working towards 1.0. This is moving at the speed of standards, but there is a preview 1 version and a preview 2 version that's sort of less widely supported, but it's still out there. But it's usable already. And WebAssembly is a very cool platform, and many of the other talks we've had today mention WebAssembly as this target because it's very powerful. It brings together portability and web technology and running native code on the web, but also running stuff securely. Now, back to WCLAP. So, why would we want to do this? Number one is it's safe. So anything you run as a WebAssembly module has a very limited scope of what it's allowed to do. And although it has access to stuff through this WebAssembly System Interface, it only can do things in the directory you give it. It can only open sockets if you let it. So it's sandboxed, in a word. That means that you can run it in a VM. You don't need code signing. That's good for developers. It's good for users as well. Every one of us has a virtual machine that we use every day, which is the browser. And you don't think, oh, is this going to steal all my data when you click most links? Like, we know it happens, it's out there, it's a risk, but generally, browsing the web is safe. And I would like trying out a plugin to be as seamless and as low risk as looking at the web page for that plugin. It's still pretty fast because it compiles from WebAssembly to the native architecture. There is a variety of engines that run WebAssembly. Some of them compile on the fly, some of them can compile ahead of time. There are some that transpile it to C and then use like the full C compiler. And it's cross-platform. So you compile for a single target and then it's translated when it's run. You compile it from one OS and target all the OSs. As someone who has a Windows laptop that I really hate having to boot up to do Windows builds, this is very appealing to me. And of course, it can run on the web. Now, a couple of details of how you would do this. I'm not going to go deep into the gubbins of it. There's more detail on some project websites that or GitHub organizations that I've written up. You export a pointer to the C struct, which is this clap entry pointer. This is standard. This is how all clap plugins work. In WebAssembly, you also need to export malloc because the web clap has its own memory, which is sandboxed, and so you need a little space of memory so you can pass in your own audio buffers and stuff. From that, you can access the structures. You can use the full clap API. And there is a WebView extension, a draft extension in clap. But, you know, there can be others. There's people working towards a web GPU, so you can directly access shaders and stuff from the WASI interface. And as this technology grows, because we're just reusing two existing technologies, we can grow with it. Here's a rough sketch of how one of these modules is structured. So it exports two things, malloc and this entry and the function table, so I guess 3, and the memory, so that's 4. But yeah, the host has a little section of the memory that it uses for its stuff, and then this clap entry points to a C struct that's inside that memory, and then everything's gravy. Yeah, hang on, so these are the reasons why I like this. But where are we now in terms of what this project does? I've been writing these web claps, and we've got some written in, I write them in C++ mostly. There are Rust ones, which just from the Clack demo stuff, you just target WebAssembly and it works. There's AssemblyScript, which is a TypeScript-derived language which targets just WebAssembly, and you can write clap plugins in this. That's cool. I have an example browser host for loading these and a JavaScript library that helps kind of wrap these into an audio worklet node. I have a native bridge, which means you can run these plugins in your native DAW. So you have a plugin which, when it loads, scans for these WebAssembly modules and then loads them as clap plugins. And that is sort of the tech which would let you try something in your native DAW by just clicking a link and not have to have installers and code signing and the fear that you're giving someone full access to your system. So I have a couple of examples. So firstly, I've got a set of open source effects, the basics set, and this is running as a clap plugin in the browser in the test host. So this is just an analyzer. Here is the same plugin running in Reaper through this native clap bridge. So this is a WebAssembly plugin, the exact same code as before, and it's running there. Here we have, let's see what else we've got. Oh, this is the gain example from the Clack set, so that's what it says on the tin. What else have we got? Oh yeah, here's fun. This is the AssemblyScript one. I'm going to need the keyboard for this. No, that's not right. Yeah, it's just, and that's cool. So yeah, this is the sort of the set of effects that are in my open source basic set. I just compiled them. Here's a sort of vocal pitch correction thing. Again, this is just an iframe. You can put anything there, and you can see my extremely good web design skills there. This is someone's husky. I've been using this web clap thing for everything, so every time I send someone a little demo of some DSP, I tend to just wrap it up on one of these links so that you can try it out. And so this is the pitch shifter that I've been developing, which is sort of a low latency thing, and it's, yeah, let's just have a quick listen. Yeah, so those are examples. There's Rust, AssemblyScript. There's this GitHub organization, which at the moment is just me. And I've been writing, this is a quick description, just the technical version of what I've said here. It tries to make it like helpful for both web people and coming into like the native audio world and native audio devs who might want to use WebAssembly. There's a few different projects here. Here is where's this? This is the AssemblyScript example effect. So here is our gain plugin. Let's look at that. There we are. This is, I wrote a little wrapper so that you can write these clap plugins, and it's based exactly on the clap helpers in C++. Plugin process, audio buffers, parameter handling, audio ports, done. Yeah, so you might ask, why am I doing this? I'm a DSP guy. That's a really good question. I've got enough open source projects going on. I've got this big list of repos here. And despite people who very kindly come and sponsor, shout out to various people who've sponsored features, and undoubtedly I've missed a few. Basically, I am doing this and I've written this because I believe that this is a good idea. I think that clap is good. I think that WebAssembly is good. And I'm kind of worried that if I didn't do this, we'd end up with something worse. So things that are invented wholesale, things which don't have a battle-tested API and extension mechanism and haven't been used in commercial plugins, something which is not safe and sandboxed, any web audio plugin format which has JavaScript in it means you have to load that JavaScript into your web door, which actually is a security issue because it's running in the same context as everything else. If your web door is saving your project to Google Drive, every plugin would have access to that Google Drive. This is sandboxed on native machines. It's sandboxed on the web. And it doesn't have any JS in it, which is, I think, good because JavaScript is not a real-time safe language. You can carefully write real-time safe code by looking up the details of how the leading two JavaScript engines work, which is horrifying. But a better question is, why aren't you doing this as well? I would really like some help with this. I think it's really cool, and I believe in it, and I would love to kind of get some more things started. All right, thank you very much.
Who wants some pizza? Anybody hungry here? Woo! Me too. All right, we got some pizza in the back. Now we're going to go on a break, I think, for 30 minutes, and then we'll be back with our final speaker. So one more time. Feel free to come sit up towards the front. Come close. All right. We hope you enjoyed your pizza. And so for the first talk with Audio Tool, we talked about collaboration. Second talk, we talked about building plugins to work on the web. And now for this talk, we're going to be talking about how we build plugins and new ways that we can build plugins. And I'm very excited to have another good friend, Oli Larkin, who joins us all the way from Germany. And he's a software engineer at Ableton. But today he's here to talk about his iPlug3 framework. So this is an open source framework for building audio plugins. And I'm very excited because Oli has been taking a dive into LLMs and their capabilities, and that has been a large facilitator on how he has been building this next version of iPlug, which has been an open source library that's been going on for quite a long time now. And so this talk will be about the future of building audio plugins and how Oli sees that world. And without further delay, I'll pass it over to Oli Larkin. Please give him a hand.
Thanks, Josh. Is that okay? Can you hear me? Good. Yeah. All right. This is yeah. I've vibe coded this presentation, so let's see how we get on. Yeah. iPlug3. It's the latest incarnation of kind of my life's work in a strange way. I've been working on plugins for a long time, and yeah, iPlug originally wasn't my creation. It was a kind of liberally licensed VST2 and audio unit only framework that I took over. It was originally made by the people who make Reaper. And yeah, way back in 2010, 11, I used it as a way to sort of get into programming C++ plugins. And I've been maintaining it and tweaking it and updating it, yeah, over many, many years. So yeah, the last talk was very exciting. I have done a fair bit of web audio, WebAssembly stuff myself, and yeah, iPlug 2. I don't know if you've tried it, but it lets you build audio plugins to target the web. I was part of the team that did the web audio modules, which was a kind of proof of concept API for making plugins run on the web, which we announced at ADC about 10 years ago. Anyway, I'm totally behind WebClap, as you will see shortly. Anyway, I wanted to sort of give a little update about where iPlug 2 is at, because iPlug 2 is not abandoned. This is a passion project. When I have time, I tweak it, and I've got about 100 branches of crazy ideas that I've had over the years that still need to get merged. And yeah, it is a liberally licensed audio plugin / app framework. It can have different graphics backends. It has this graphics abstraction called iGraphics, which can either use a thing called NanoVG, which is very lightweight, or it can use this library Skia, which is the Google graphics engine that powers Chrome and Flutter and Android. And Skia is a really heavyweight library, and I've spent a long time figuring out how to build it. And yeah, it gives you amazing quality graphics rendering, but it's a bit of a pain to build, and it's big. iPlug 2, yeah, supports WASM, and I've been updating that functionality recently. It's got quite extensive library of widgets, controls, and yeah, a lot of the ones I've done recently are kind of audio visualizers, and so you've got like drop-in controls for spectrograms and spectral analyzers and VU meters and things like this. And there's a kind of a pattern that lets you easily get the audio samples from the audio thread and get them into the GUI, and that can work in a special way when you're targeting the web and stuff like that. And lately I've done a lot of work over the last year making it work really nicely on Vision OS. And before that, iOS, and getting AUV3 working. I think Vision OS is fantastic. Unfortunately, it's super exclusive. You have to be able to buy one of these very expensive headsets, but fortunately my open source funding for iPlug2 helped with that. And yeah, I have a side project which is a kind of spatial audio file player app, and I'm really passionate about making visualizers with that. So I've kind of got a reality kit, mixed reality GUI library built on top of iPlug for doing sort of immersive visualization of ambisonics, which is a spatial audio format. And yeah, as iPlug2's matured, I've kind of made it easy to swap out the GUI part for something else. So it supports Swift UI as a GUI, and web views, and also this thing called Metal CPP, which lets you do nice visualization, getting as close to the metal as possible on Mac systems. And yeah, one thing that the users have been clamoring for many years is CMake support, and there was sort of a branch that's been there for about 8 years with CMake support, which I never managed to merge. And before Christmas, I've been playing with these AI tools for the last few years, changing subscriptions and trying different ones out. But yeah, I got Claude Code like in about late November or something, and yeah, it started to get really good. And the model Opus 4.5 was considerably better than previous ones, and the whole sort of agentic workflow that Claude Code enables was also considerably more powerful than what I'd been doing before. So that enabled me to land CMake support in iPlug2, which involved, the reason I hadn't merged it was because there's so many different examples, so many different targets, and all these kind of handmade Xcode projects, Visual Studio projects, which I had to go through, and I wanted to add, basically the same functionality that I had in these handwritten projects, but via CMake, and that was just a huge amount of work to do it properly. And Claude Code just let me crunch through it really, really quickly. And I started thinking about how I could make iPlug2 a bit more suited for this kind of agentic coding workflow. So I started building like a CLI target, a command line interface, so that I could drive or render out audio signals on the command line and things like that. But I was making so much progress so quickly with this tool that it struck me now might be the time to basically make the plugin framework that I've been wanting to make for ages, but throwing away all the sort of legacy code, starting from scratch using Claude Code, and yeah, just go for it with all of the ideas that I've learned over 15 years of messing around with iPlug in one way or another. So yeah, I thought I would start a new project. Yeah, this is kind of what many people's GitHub profiles look like. Claude Code Opus 4.5 dropped at the end of last year, and suddenly there were just a massive amount of stuff being built. And yeah, one thing that you might be aware of is that there are things coming on the market now which are basically letting someone without any programming experience create an audio plugin just by prompting. One of them is using iPlug 2, my liberally licensed audio plugin framework. It is not a free free service. That's my problem. I put it out in the world for free, so that's what to be expected. But it's a pretty impressive project. What these guys have made. But that's only one of these tools. There's a few other ones, yeah, this is causing a bit of alarm in some sort of plugin developer circles, because there was already an abundance of audio plugins, and it's already incredibly hard to launch a new brand and kind of get people to notice your thing. So yeah, these new tools are going to inevitably affect this. Yeah, I'm not sure I have the answer, but my iPlug 3 work is kind of embracing some of the same technologies, but trying to do so in a way that hopefully lets people who really care about making really good products, really good design, really good DSP, really code that's really easily maintainable and not just kind of a totally vibe-coded mess that you have to throw away or pay someone to fix. It's kind of designed to be somewhere in between this. It is allowing sort of totally prompt-based plugin development, and I could even demo it here, but I kind of think the novelty's worn off. I don't know if you've seen this happening. Josh did a video about it recently, but you can just talk to Claude and prompt a plugin into existence. You can do it with Juice. You can do it with iPlug 2. But yeah, I think that this totally new paradigm of programming kind of demands a slightly different kind of audio plugin framework or app framework. Also, I don't know if you remember, or anyone's old enough to know what they're looking at here on this screenshot, but if you were making plugins in the early 2000s, you might remember that an awful lot of plugins appeared which had these blue sliders, and some of them were really rubbish. These were made with a tool called SynthEdit, and I don't mean to slight SynthEdit at all, because I think it's fantastic, and actually it's what got me into audio programming. This is a image from the 2004, I can't remember what month, but it's from Sound on Sound in 2004. And this plugin in the bottom left-hand corner, which actually uses some stock GUI elements from SynthEdit, is a thing that I made, a string resonator plugin. So yeah, there were loads of bad SynthEdit plugins, and there were people who got really, really into it and tried hard to make good ones. And the ones on in the screenshot are not necessarily the best, but there were some really amazing SynthEdit plugins. And the technology behind SynthEdit is actually really good. It was sample accurate. It was using kind of voltage control paradigms way before VCV rack or like modular synths became popular again. Yeah, it allowed people to make really good things if you really cared. And I want to sort of use this analogy with this whole vibe coding or agentic engineering, as we need to call it now. I think that you will still be able to make really good stuff if you really care about what you want to make. And there will unfortunately be a lot of slop, and the fact that you can automate AI to make these things is a bit different. You know, back in this time, you can automate a SynthEdit plugin. But yeah, this is just the way things are in 2026. There was also a terrible war in 2004 happening in the Middle East, which is, yeah, another awful thing. Anyway, my thinking for iPlug 3 is to separate it into two components. One of those is a sort of headless audio plugin abstraction. And yeah, as Geraint said, many people are using clap as a baseline format for audio plugins. I'm not so much into that because I actually see this as a generalized audio processor abstraction, not just for plugins. But yeah, you can target plugins, you can target standalone apps, CLI tools. One really awesome thing about Claude Code is that I'm rediscovering loads of command line kind of computer music tools like C-Sound or the Composer's desktop project. These things work amazingly well when they are orchestrated and automated by Claude Code. And I want mplug, this audio processing abstraction part of iPlug 3, to be able to make these little command line processors. I'm also pretty much into this MCP topic. If you don't know what that is, it stands for Model Context Protocol, and it's the current way of kind of connecting an LLM to another piece of software. It's got a bit of a bad rep lately because it doesn't use the LLM's context window very efficiently. So I prefer to talk about like just agentic control of software in general rather than MCP, because maybe it doesn't stay around. But iPlug 3 can produce what are called MCP apps, and these are plugins for Claude Desktop, or plugins for ChatGPT. It can create a little bit of UI and an audio processor, which happens to be a wclap, inside of your chat window. This is a relatively new thing where they've added a UI. Anthropic and OpenAI have collaborated on a kind of UI element to MCP servers. And yeah, you can basically get all the power of this amazing frontier model and control your audio processor or your network of audio processors directly inside of ChatGPT or Claude. And there's a thing called MCPB, which is like a one-click install for one of these. So yeah, you can build all sorts of interesting local-based audio tools that you just install into your chatbot. And when you combine these with things like Claude Cowork, which is a kind of GUI version of Claude Code, you can orchestrate all sorts of interesting audio processes by pointing at a folder full of sound files and say, process each one. Claude, please process each one of these with a different audio effect. This kind of thing, which I think could enable some really interesting creative outcomes. So yeah, mplug stands for micro plugin abstraction. It's a really lightweight, tiny thing. It uses CMake, which I was never a big fan of, but now Claude writes all my CMake, so it's not a problem. And I'm using Choc a lot. That's Jules's open source library. It's got lots of nice kind of audio buffer abstractions and audio MIDI routing things that I use. And it's got a sort of WebView, single header WebView library. So although this is a headless plugin abstraction, you can easily pop up a kind of default GUI using that Choc WebView. And it's designed for agentic engineering, so it can build out a CLI tool that can be completely controlled and automated from the LLM. So I'm just going to quickly show the MCP app. This is a chat I did earlier, and you don't really need to read all the text, but I prompted my chat 303, which is a MCP app that I've built with iPlug, or mPlug iPlug 3. I said, can you make me a hypnotic acid raga 303 at 145 BPM in the Phrygian dominant key? I want it to be fast-paced with no delay. Let's make every 16th note a hit. Don't know what that meant. With some slides and octave jumps. Yeah, I've got it to respond in a sort of Studio Geezer type way. I did want to hook it up to like a text-to-speech thing, so maybe it has the voice of Super Hands or some kind of junglist producer. Anyway. It's not quite banging enough yet, but I've got to iterate on it, and yeah, I want to make it, you know, really look like a 303 and stuff like that. So yeah, that's a web clap plugin running in yeah, this MCP server, which is all using, it's like a Node.js type setup behind the scenes. So that's one part of iPlug 3. The other part is MGFX, which stands for Massive Graphics Engine. And this is using some of the stuff that I've learned from my iPlug 2 experiments. But yeah, one thing with iPlug 2 was that it never supported Linux, and one of the people on my Discord suggested I try SDL3, which is a latest incarnation of the SDL library, which is a sort of games programming. It stands for Simple Direct Media Layer. It's got like its own kind of OpenGL type abstraction, but importantly, it's got the whole sort of cross-platform windowing stuff, and it supports all the platforms that I want to support. And yeah, I managed to get some pretty good results using that as the sort of windowing layer. And then I'm using WebGPU native for this kind of cross-platform GPU graphics abstraction. And then on top of that, I'm using Skier Graphite, which is the latest and greatest version of Google's Skier library. And yeah, Skier and Dawn, they're pretty big libraries, so I build them on GitHub. And yeah, these sort of agentic coding tools were incredibly helpful to build all these things for all the different platforms, because I set up what's called an agentic coding loop, and I don't know how many of you are familiar with trying to build stuff in the cloud on GitHub Actions, but it's typically a really annoying, slow process where you tweak something and you push it to the cloud and then it fails. And then, yeah, if it's a long, big build, it might fail in an hour's time, and then you have to start it again, and it's really tedious. So I just set the agent up in a loop, like using the GitHub command line tool to basically poll the status of the builds in the cloud, and it built it for all the different platforms eventually. So yeah, Skier has its own shader abstraction, Skier shading language. It's a bit like GLSL, so that's used for like sort of very simple shaders on in the 2D world. But using WebGPU allows me to use WGSL, which is the WebGPU shading language, which also supports compute shaders. And yeah, compute shaders are really interesting for doing some kind of heavy audio processing, such as like additive synthesis or maybe some kind of machine learning inference. And that is great because you've got a cross-platform compute solution there. It's going to run on Windows and Mac without kind of having to target Core ML and Direct ML, which are like different inference engines for machine learning stuff on those different platforms. Yeah, Skier's like very heavyweight, but it's kind of the best in class graphics rendering, and particularly for like international text, it's very good. I've got a pretty extensive widget library, which doesn't, I pulled it out, it's probably going to include accessibility features. Includes a lot of things that iPlug 2 didn't include, like scroll views and a lot of the kind of 2D graphics library type things that people expect. Yeah, I'm sort of thinking that accessibility, like screen readers, are a thing of the past now because, yeah, if we're talking to voice agents and they're controlling our software, we want to express things in natural language, and yeah, if you provide like an overview of how the software works to the agent, it just seems so kind of backwards that a screen reader software would have to kind of scan the GUI that's designed for a sighted user, for instance, and so I'm not sure, I might be wrong, but I feel like screen readers technology is a thing of the past, so that's maybe why I don't put the accessibility stuff in iPlug 3, but let's see. Yeah. So I do a quick demo just to show that it does exist. It's looking a bit like this at the moment. And build, release, class widgets demo. Okay, so this is a very simple kind of GUI, but it's trying to do this Apple liquid glass effect, which is so controversial. And yeah, you've got a bunch of shaders going on here. So these are Skia SKSL shaders on the widgets doing this refraction. And there's a shader in the background doing this kind of lava lamp animation. And you can switch them. One important thing about this is that you can code your plugin UI in JavaScript. Yeah, there are JavaScript bindings for everything. So yeah, I can, what would be a good one to show? I mean, I'll just show a game that I just vibe coded, single prompt. Oh. Anyway, it's very impressive, isn't it? 8 bits or whatever. Anyway, you can do yeah, so one thing that was missing from iPlug 2 was it's always like a single window framework. So if you wanted to pop up a preferences window or something like that, you couldn't. So yeah, that's no longer the case. That's all thanks to SDL3. Here's some more psychedelic shaders. And of course you can do kind of synthesizer type UI. Oops, got some kind of resizing bug. Yeah, you can do that kind of thing. Here is a oops. This is a additive synthesizer, synthesizing all the modes of a string on the GPU using web GPU compute shaders. You can also do sort of 3D stuff using raw web GPU. So yeah, it seems like often people want to use some kind of 3D in their audio plugin, especially people who are into spatial audio like me, and they want to display a sort of virtual room. So I have basically dictated this framework to Claude Code mostly at the beginning of the year. I started on the 1st of January, and I kind of done it within 10 days. And since I got back to work at Ableton, I've been extremely busy, and I haven't made much progress in that time. But yeah, the whole sort of designing for agentic engineering thing is building out the framework so that it builds really quickly, so that the agent can just keep on building. Like if it crashes, it can get the stack trace, and then it can act on that. It can capture screenshots. One thing I didn't show with the widget library, I've got this kind of like Terminator style heads-up display where you can say, please take me a screenshot of the knob that's in the top right-hand corner, and it does a little animation, which is totally unnecessary, but kind of fun. Yeah, you can also render out audio. The agent can like validate some DSP code by rendering audio and then piping it into some kind of audio analyzer that determines whether it's correct or not. And of course, you can run plugin validation and benchmarks, all driven by the agent, which you interact with plain text, with natural language, sorry. Yeah, these LLMs, they're multimodal, so the screenshot stuff, the LLM can tell whether it's done the right thing by looking at the screenshot that it takes. And yeah, the workflow becomes much more about like defining the right criteria to validate the feature that you're trying to implement, and setting up the feedback loop so that the agent can just crunch away at it in the background. So yeah, this all makes it very easy to code things, and sometimes, well, if you look on LinkedIn, there's people that saying coding is going to be a thing of the past and going to be finished, by the end of this year or whatever. I'm not so sure. I have been in this situation where Claude, the audio was glitching, and I had to ask Claude, you did do that on the audio thread, right? And it hadn't. It had done it on the graphics thread, and it was sending all the audio processing to the audio thread, and it was just, it'd done it in an absolutely terrible way. So yeah, these things are totally fallible and very forgetful, and you have to learn how to work with them and kind of use the knowledge that you might use just doing normal engineering to do things properly. So yeah, I'm not so sure. These tools are definitely not worth ignoring, in my opinion, and I'm fully embracing them. But learning the fundamentals definitely still important. But yeah, in order to make the most of this new paradigm of coding, I think we need to be able to build things fast to let the agent iterate on them. iPlug2 was kind of compiling a load of stuff unnecessarily for like multiple examples and things like that. So I've tried to correct all of those kind of things. Yeah, the thing that you're testing needs to be able to be parameterized via CLI and controllable via CLI, command line interface. Maybe having this kind of model context protocol connectivity. Anything that can be, errors that can be produced at compile time are helpful. So I'm using C++20 and a bunch of C++20 features to help with that, so that things get caught as early on as possible. It's all got to be designed for token efficiency, and yeah, there can be a bunch of side tools that help all of this. So I've got specialist tools for analyzing audio, or tools that analyze the screenshots that just say, okay, it's totally black or it's totally white, rather than using the tokens of the LLM to do that, which is a massive waste. So yeah, I hope to be a bit more close to releasing it by now. I am undecided about the license. There's huge controversy with all of this stuff, of course. These LLMs are undoubtedly trained on huge data sets of code, some of which may be not liberally licensed. I don't know. So yeah, there's an issue there. There's also the issue that I don't want this just to be used in someone else's AI text-to plugin generator thing. So I'm thinking about different things. I'm thinking about maybe releasing it as or for Mac at least, as a XC framework, which is like a pre-built library that you just link to. Maybe the mplug thing is source code, but the graphics thing is a pre-built library. Stuff like that. I'm thinking through the options, haven't decided yet. If anyone's got any ideas, please let me know. So yeah, I've made a manifesto, which is kind of a much more detailed version of this talk. If you haven't seen it already, you can find it at this link. Yeah, that's it. So thanks for listening.
All right. Thank you so much, Oli. Such an amazing talk about the potential future of audio plugins and audio software. Wow. Just wanted to take a moment to once again thank our sponsors for this event, Focusrite, Moonbase, and Audio Tool, and of course, Point Blank. Let's give it up one more time for the sponsors, especially Point Blank for letting us have this space. Also, big thank you to all the speakers, to Chris, Silas, to Oli, and to Garrett. Let's give it up a hand for all the speakers and the amazing presentations. Cool. From here, it's networking time. So I know that there are some people here that are more experienced in audio programming, some people here that are not so experienced. So I would highly advise you, please mix it up. Please don't be afraid to come up to people like Oli. We got Jules in the back there as well. Please mix it up with them, start conversations. This is all about networking, all about connecting and collaborating. And this is an exciting space to be in. As Oli was saying, it's moving super fast. We don't even know where we're going to be in 3 or 6 months. But I know that we'll be creating. We'll be creating something. I don't know whether it's going to be vibe coding, whether we're going to be doing back to just hand rolling C++ or not, but we'll definitely be creating. And I think that it's a great time to lean into that, to lean into creating, leaning into the amazing possibilities that we have. With that, I'm just going to wrap it up. Thank you so much. Yeah, hang around, grab some more drinks, and let's connect.